Hello everyone, we are group 7 and this is Mohammed Siam and our topic is behavior based grade prediction for MOOCs via time series neural networks. This is our outline. So we all know about Coursera, EDX and Udemy, right? They have partnered with content providers to deliver hundreds of thousands of courses. These are called massive open online courses, MOOCs, which exploded in popularity over the past 5 years. An estimated 35 million people signed up for at least one MOOC in 2015. For all their benefits, the quality of MOOCs has been the target of criticism. Research has pointed to their low completion rates, below 7% on average. As a result, to enhance student engagement and knowledge transfer in these online settings, research on MOOCs is getting its attention. MOOC platforms, or we can say e-learning platforms more generally, collect data about their users. This has ignited interest in data mining approaches, and to see the value of this approach, the authors suggest considering the three most dominant modes of learning in MOOCs: lecture videos, assessment questions, and social discussion forums. Of course, there are some other research on these, but the author's work is fundamentally different from these in that it focuses on algorithms for predictive analytics. Methods for predicting student success have been presented and studied mostly for conventional brick and mortar and online learning environments. Instead, they take into account performance prediction for MOOC environments where there is a lack of student performance data and behavioral modeling is therefore necessary. In this context, a few new papers on predictive analytics for MOOCs have been published, offering algorithms to forecast assessment results and dropout rates. They used video assessment and time-related characteristics to propose a linear multi-regression model for assessment performance. The authors employ neural networks on the same collection of features to improve prediction accuracy, with RMACs as low as 0.06 compared to 0.16 to 0.23 in. Now let's talk about the algorithms the authors used. The algorithm predicts MOOC students' final course grade based on their performance on the first evaluation and their behavior when viewing lecture videos. Some clickstream variables for video viewing, such as the quantity of rewinds, the average playback speed, and the percentage of completion, are related to quiz performance. Using two MOOC datasets, they evaluated two algorithms, FTSNN, which learned purely from quiz, for example, assessment aspects, and SNN, which learned from both behavioral and quiz features. Both algorithms beat their respective baselines, with FTSNN increasing RMAC over the naive baseline by 49% and IFTSNN by 61%. FTSNN performs best in situation with constant assessment outcomes, showing that the performance-only approaches can be adequate for the earliest identification. Here we can see the summary of different components of learning outcome for learning outcome prediction method in figure 1. The figure 2 shows us the sequence of average CFA predictions made online as a student moves through the course. Here each step is train, retain and prediction involves all the components in figure 1. Figure 3 shows the general sequence of lecture videos and in-video quizzes in MOOC or um, massive of open online courses. And this is it from me. And the rest of the parts of the presentation will be presented by my group base. Thank you.
Assalamu alaikum to dear faculty members. I am Tasbir Afat and I will be presenting the methodology and datasets analysis section. As per the methodology section in the paper, it summarizes the main components of the grade prediction and its models. In the paper, the authors have mentioned a method for predicting course grades from behavioral data in MOCs using set of features in a time series neural network. Their model overcomes the challenge of data sparsity, which we can find in the existing models. Also, personalized prediction models are essential for predictive analysis in MOCs as per the developed model by the authors. Also, it demonstrates the benefit that different forms of data prior to grades and clickstream behavior offers for the grade prediction in the MOCs. The author's algorithm uses each student's video watching clickstream features and the previous average CFA grades as inputs to predict each average CFA grade for the number of questions that the students have answered. Their model can also be understood as the minimum number of questions a student must answer before the predictions on future average CFA will be made. The authors have used phi to denote the model to emphasize that they have trained and the model they have trained the model separately for each student. Thus, each student's neural networks will have different parameters, which creates a variety in the dataset, which helps to make the prediction more accurate. The developed network by the authors is a type of network that is known as the feedback time series neural network compared to the previous and existing models, which is the IFTSNN. And since it has a clickstream input side, FTSNN does not use the clickstream features, which is a major difference for compared to the developed model of the authors in the paper. In addition to the neural network parameters, there are several configuration parameters that the authors have tuned for a time series neural network. As I have mentioned before, they have developed the method for predicting course grades from behavioral data using set of features in a time series neural network. However, the results for the chosen parameters are sufficient to demonstrate the feasibility of using neural networks to predict the MOC students' performance. As you can see from figure 4, these are the examples of students' average CFA grades throughout the courses. For students who have taken all of the 92 quizzes, their predictions and their graph chart is shown on the left, and 29 students who have taken only 69 quizzes for simplicity. Uh, but among them, only the first 10 students were plotted against the number of quizzes for the CFA grades. As you can see, there are significant changes when the data is less and compared to when the data is more in the data set. From the graph chart, this is very much visible. As you can see, the plotting in the left is vertically aligned with the number of quizzes axis, and in the right it goes upwards compared to the number of quizzes. And in the figure 6, you can see a graphical representation of IFTSNN, the previously existed model. And in figure 6, you can see a graphical representation of FTSNN, the developed model by the authors. As for the datasets and analysis part, uh, it summarizes that students who have completed more of a video are more likely to be successful on the corresponding quiz, given the data collected from the author's trained model. And as for the mean value, the difference in the means are insignificant compared to the existing model and the author's developed model. Also, two different courses exhibit somewhat difference, means for CFA and non-CFA responses, difficulty of a course affects students' learning behaviors, and thus the data might be uh, different and the data might be different from for different learning behaviors. The authors have performed statistical analysis on the relationship between the input features and CFA scores for each data set, and it provided some intuition for the predictor results in the section 4, which is mentioned in the paper. The figure 8 shows the means and standard deviations of all 8 clickstream input features for both courses, considering the CFA and non-CFA responses separately. In order to motivate training individuals models for each student, they have considered the effect of using algorithms trained on one NI student to predict another NI student's average CFA scores, uh, which overlaps some of the error portions of the dataset trained models output. The authors have also divided their datasets into different partitions for evaluation in the section 4 as mentioned in the paper. Due to the data being varied, the authors have divided their datasets so that they can compare the different results, and they can measure how datasets have an impact on the output of any trained model. As you can see, I have mentioned in the previous slide the figure 8. This is the tabulated statistics, the mean and standard deviation. And as you can see, the top row for each feature corresponds to CFA responses and the bottom two non-CFA responses. And the difference in means are comparatively insignificant. Now I'll pass on the presentation.
Good evening and Assalamu alaikum. I'm going to talk about the dataset groupings part of the paper. In section 5, the authors offer student interventions that utilize their prediction algorithm to aid vulnerable or struggling students. Due to their lack of experience, these students may have relied more on the videos to learn the presented material. Therefore, the clickstream input features could provide more insights into student performance than for the NFMB course, resulting in a more consistent improvement of the IFT-SNN algorithms compared to the FT-SNN algorithms. To determine this, they retrained their algorithms while removing specific features and compared the performance of the retrained algorithms to that of the IFT-SNN technique. The authors find that RMSE in both courses increases significantly when only one feature is utilized as compared to the IFT-SNN approach with all clickstream characteristics, indicating that each feature contain information that is essential for predicting average CFA grades. As new student data is collected, their prediction algorithm will be executed online and retrained. Now on to the analysis part. Students who completed at least 10 quizzes were utilized to train and assess a reliable model. 70% of the funding was allocated for training, while 10% was allocated for random model testing. Using RMSE, the algorithm's accuracy was evaluated according to IFT-SNN forecasts. Anticipated CFA grades closely resemble students' actual CFA course grade distribution. The author's prediction system tracked to the oscillations, notably those for the NFMB students because the NFMB course contained more assessments than the NI course. For all courses and including input data, the IFT-SNN and IFT-SNN forecasts outperformed the naive and linear regression baseline by a wide margin. As anticipated, the lasso regression method outperforms the naive baseline in every instance. On the basis of the marginal performance benefits, the author's training technique prevents overfitting for IFT-SNN relative to FT-SNN. As the volume of the data increases, the RMSE improvement relative to the naive baseline decreases, resulting in 61.1% and 49.9% overall RMSE improvements for NFMB respectively. The IFT-SNN and FT-SNN algorithms achieve an average RMSE of 0.0505 on students who responded to fewer than 10 quizzes, indicating that these algorithms performs well on students who responded to an extremely small number of questions. The clickstreams based input characteristics of IFT-SNNs increase CFA grade estimation by an average of 11.5% for category A and by 10% for category C. The clickstream input characteristics can provide greater insight into student performance than the NFMB course, resulting in more consistent progress with the IFT-SNN algorithm than with the FT-SNN algorithms. Comparing the RMSE in both courses with only one feature to the IFT-SNN algorithm with all clickstream characteristics demonstrates that each feature includes useful information for predicting average CFA grades. No one feature contributes considerably to the improved performance, but the combination results in a significantly reduced RMSE. Because the parameters of the neural network are modified as the number of students rises, the neural network models developed by the authors can be used for both online and offline prediction. Thank you. My teammate will take from here.
Hello, Assalamu alaikum. My name is Muhammad Junaidul Islam, and I'll be talking about the future works that can be done by the proceedings of this paper. The authors used neural networks as their prediction algorithms because there is a little association between the input features and the CFA grade as well as a little time series data available. The paper shows the viability of using historical quiz performance and clickstream data to predict performance rather than firmly establishing the best kind of algorithm to perform these predictions. However, other time series prediction methods might also be efficient when compared to the naive baseline. Future research in this area could take the encouraging step of thoroughly comparing the accuracy of their findings to those of the other types of algorithms such as nearest neighbor and other neural network techniques, including different neural network configurations. The neural network approach used by the authors might be improved in the future to be topic specific. Now, to summarize up, the authors presented a novel method for predicting a student's grade evolution in a massive open online courses, which is also known as MOOCs. Their method overcomes these difficulties by incorporating another, richer type of data collected from each student, lecture video, watching clickstream, into the machine learning feature set and using it to train a time series neural network that learns from both prior performance and clickstream data. They discovered that their algorithm outperforms a baseline of average past performance by more than 60% on average and a lasso regression baseline by more than 15% using two MOOC datasets. They also demonstrated that, despite these gains, none of the behavioral features are particularly correlated with performance when taken alone, emphasizing the importance of considering the combined effect and nonlinear predictors. Thanks for having patience here. Thank you.